Hello all. In this session, we are going to understand the term distribution in statistics. What is this distribution? What are the various distribution techniques? How we are going to calculate the probability in each distribution technique, we are going to understand in this session. Now, when it comes to the distribution, it already gets related to, we already knew about something called a dispersion. This distribution is somewhat closely related to the dispersion with some small changes. For that, let us recall what is dispersion. What is dispersion? The dispersion talks about how widely the values are spread in a data set from the mean. We know what is the mean, rather the midpoint. From the midpoint, what is the range of these elements? How spread those are from this mean or from the other data point in the data set. That is actually is dispersion, right? What is the distribution? Distribution also talks about the range, but this rather is going to talk about the shape of the data set. For an example, I will tell you that, let us take an example. For an instance, there are salaries. Take the salaries in India or with respect to one city. India is a huge data set, so let us take one city. In one city, let us collect the salaries. When you take the salaries, when you plot an axis, the dispersion is going to talk about what is the maximum salary, what is the minimum salary, and what is the range of the entire salaries. It's going to talk about the maximum and minimum and how widely these values are spread across from the mean or from the other salary point. This is what the dispersion. But the distribution more talks about the curves and edges, higher edge or lower edge. It is going to talk about the shape of the data set. For an instance, take the salaries. When it comes to the salary example, obviously most of the salaries are falling under 30,000 rupees. Now, some salaries, some higher segmented people's salaries will be around crores. For example, Ambani or Adani earns crores and on average every day they earn in crores. These values are going to contribute more towards mean, and then we are going to have a right skewed one. The right side one will skew this entire shape up since those are going to contribute more to the mean. So this is what the distribution. In distribution, we are going to talk about the shape. In the dispersion, we are going to talk about the range. But both actually, when you look at closely, they are going to talk about a range, okay, in which distribution gives more importance to the shape, and the dispersion is going to give the more importance on how widely or how closely the data points are being clustered. Okay, and we have various techniques for the dispersion that we understood, that is variance, standard deviation range, and interquartile range. Now, what are the various distribution approaches? There are several distribution approaches such as exponential distribution, binomial distribution, normal distribution, and a standard distribution. In this session, we are going to understand about the exponential distribution with a suitable example, with the right example through which we will completely be able to understand and perceive the topic to the extent that is desired. Now, every distribution function will have a probability density function. Every distribution function will have a function through which we are going to calculate the probability, which is called probability density function. We will have a look at the probability density function in we are going to talk about a probability density function in the exponential distribution. In the exponential distribution, f of x given a parameter lambda, this is what? F of x given a parameter lambda is equal to lambda into e power minus lambda x. This is how we are going to calculate the probability. Here, what is the lambda? Lambda is the rate. The lambda is the rate. Obviously, you know E is a Euler's number, and a total probability of x given the parameter lambda is equal to lambda into e power minus lambda x, where x is greater than or equal to 0. Now, understand this by using a simplest example. Let us take an example. For an instance, you actually are waiting for a bus in the bus stop. Now here, let us say you are expecting the bus to come in the next 10 minutes. That is what we do. Generally, when we arrive to the bus, we just expect the bus to come within the 10 minutes because, that is how we calculate the time for awaiting a bus, right? But understand here, it's just all about the probability. As long as we don't know the timetable of the buses, the frequency of the buses, we would expect the bus to arrive within the 10 minutes. Here the thing is, there are few things that we need to understand before we directly take an example. We need to be able to understand the properties of the exponential distribution. What are the properties? The first one is memory loss property. What is the memory loss property? For an instance, when you talk about the memory loss property, it is not memory loss, it's a memory less property. What do you mean by the memory less property? Memory less property meaning the past history of the time doesn't contribute towards the actual occurrence of the event. For an example, when you arrive at 12 o'clock and you're expecting the bus to arrive in 10 minutes, let us say the time passes by and right now it is 12:30. The bus, whether it is going to come or arrive in the next 10 minutes or not, will be the same as you come at 12 o'clock, right? Here at 12:30, how much time you actually awaited doesn't contribute towards the probability. It doesn't increase the chances of the bus. The chances of arrival of the bus in the next 10 minutes would remain the same as at 12 o'clock. At 12 o'clock, you've been waiting. At 12:30, also you've been waiting. What are the chances of arrival of the bus at 12 o'clock in the next 10 minutes will be the same as the chances of arrival of the bus in the next 10 minutes at 12:30. Here, the time that we have spent is immaterial. That is what the memory less property. Next one is the parameter lambda. In the exponential distribution has one parameter, that is lambda, which represents the rate of occurrence of the event. This also is known as right parameter. Okay, if the event happens frequently, lambda is large. Understand this. Let us take the timetable. When you have the timetable, the frequency of the buses is for every 10 minutes. Now the lambda will be large. And the rate for every 1 minute will be equal to 10%, right? Similarly, the frequency of the buses is for every half an hour. Lambda is less. The rate will fall down. So, if the frequency is more, lambda will be higher, lambda rate will be higher. If the frequency is less, lambda rate will be less. So now, let us calculate this. Calculating probabilities with example distribution. Imagine that the buses arrive at a bus stop on an average every 10 minutes. The frequency of the buses is for every 10 minutes. Now when you have come in, when you arrive at, you just would like to calculate the probability, the percentage of occurrences of the arrival of the bus within next to 5 minutes. Of course, the frequency is 10 minutes. The moment you come in the next 5 minutes, if the bus is going to come or not, will be the probability. That depends on when you actually have arrived. At 12 o'clock there is a bus, at 12:10 there is a bus, at 12:20 there is a bus. If you have come at 12:02, in the next 5 minutes, whether the bus is going to come or not depends on a lot of events. So what is the probability? How would we be able to calculate the probability? So we will use the probability distribution function, density function rather, f of x given the parameter lambda, which is equal to lambda into e power minus x. What is that? Rate of lambda is equal to 1/10, right? What is the rate of lambda? The occurrence of the event, the frequency of the occurrence of the event is 1/10, that is equal to 0.1. Now let us assume that, let us understand that we are expecting the bus in the next 5 minutes. The probability of the arrival of the bus in the next 5 minutes. Then x will become 5. Okay, rate is 0.1, lambda is fixed. Because the frequency of the buses is just set to 10%, the rate will just be equal to 0.1. F of 5, 0.1 is equal to 0.1 into e power minus 0.15. If you simplify it, you will get anywhere in between 0.0608. The answer for this is 0.0608. That means it is just around 6%. The percentage, the chances of arrival of the bus in the next 5 minutes will just be equal to 6%. Now we also need to understand the other way around. What are the likelihood of bus is going to arrive after the 10 minutes, if the frequency is 10 minutes, what are the chances that bus would come after 10 minutes? For that, we just need to take an inverse. I'll tell you. Probability of waiting for more than 10 minutes. Here for that, we just need to use something called cumulative distribution functions for this. What is cumulative distribution function? Simply at that time, P of x greater than x. Here x is maybe 11th minute or 12th minute. Okay, this 11th minute or 12th minute actually is greater than x. X is equal to 10, right? Now is equal to e power minus lambda x. What is minus lambda x? Is equal to Euler's number 2.278 to power minus 0.1 into 10, where is equal to e power minus 1. It is around 36%. So the probability of the arrival of the bus in the next 10 minutes, not rather, after next 10 minutes will be equal to 0.36, rather 36%. Here the probability density for exactly 5 minutes is equal to 0.607. The probability of waiting for more than 10 minutes is equal to 0.3679. It is equal to 36%, rather 37%. It is equal to 6%. These are the percentages of the probabilities of the arrival of the bus within the next 5 minutes or after the next 10 minutes. Thank you.